Hi, so I'm just going to do a quick rundown of doing clustering using Pycaret. So we are using the jewelry dataset for this task. As you can see, there are four feature columns, and there are a total of 505 rows. To do clustering, we simply import the clustering module from Pycaret. We set up the experiment. Here we're listing all the appropriate modules for this task, for clustering task. As we can see, we have k-means and mean shift. So for this demo, we're just going to use k-means. Now, notice how I manually set the parameter number of clusters to be 5. I believe if you do not set it manually, the default value is 4. So by default, the model will try to divide the data into 4 clusters. So here we'll just assign the model and use it to do the clustering on the data points on the data set. And here we can see there are indeed 5 different clustering labels. Now, the best way to visualize clustering is plot different types of graphs. So you can plot the distance of all the data points to its dentoid, or you can do the distribution plot. Shows how the data points are distributed across different clusters. But I find that the best way is to do this plot, which is called clustering. Okay, and this, in fact, this is how I set. How I realized the default 4 clusters didn't work well, because with 4 clusters, I mean, visually you can see there are clearly 5 different clusters. I think in the first run, I used the default 4 cluster. 4 is the number of clusters. These two clusters are labeled as the same cluster. So I visually eyeball it and think maybe 5 would be a better choice than 4. So I went back and changed it to 5, and it just works beautifully. So yeah, in this case, in this data set, 5 cluster works better than 4 cluster. And I think with the 3D representation, it's even more clearer. Of course, you can also print out elbow or silhouette, but I don't know how they can be helpful. So at first glance, oh, you think, oh, how come there are only 4 clusters? But since this is a 3D representation, you can rotate it, and voila. Now we have 5 clusters. Okay, this one is kind of small, but in a 3D space, you can clearly see that this one is separated from the others. Again, 5 is a good number of clusters with this data distribution. And here it's just, we save the model, we load it again, and we run the loaded model on a fraction of the data set, which was we simply resample it and run it on a smaller data set. Yeah, so that's all. Thank you.